We'll come again. Next model of our course is 1.3 network architectures model. These two models that we are about to talk about coming. Network architecture models. This is specifying exactly the term of the network architecture model. This is how the entire network technology was built from scratch, from zero, from the first layer ever in networking and ascending. Okay, a layer upon another, and each layer is depending on the base layer beneath it. So network architecture models is how the network science or technology is built to introduce to the human, to us, this final output that we are using today. Okay, mainly there is a lot of architecture models, a lot of companies, the old already known companies like Apple, IBM, Microsoft, or even the ISO company, a lot of them did build network architecture models for building the networking technologies and size from zero and to the final model, or sorry, the final view, the final network that we know. Okay, two types we will study in our course, which are recommended by Cisco. The first type is called the Open Systems Interconnection Model, or also known as the OSI model, which was invented by the ISO company. Okay, this one is the most important, more specific, more detailed, explains to you everything about networking in every hidden layer that you have no idea about, or maybe you do know about them if you have studied networking before or not, with other courses or with previous Cisco courses. Okay, anyway, this is the more specific model in showing to you the network with its layers, which each layer, how it's functioning, what's happening through or inside each layer from this perspective of you or from the opposite device that you are contacting with using a shared network between you. Some layers go through encapsulation and decapsulation. We will talk more about this later, also for the third point. The OSI models take your network, your well-known network that you always use, and divide it to 7 layers of technologies. Each layer is separated from the other. You might make a good benefit or good use of networking using only the single first layer, the first 2 layers, first 3, 5, 6, all the 7 of the layers. It depends about the function or the need that you want to use or make use of your network. Okay, so these 7 layers, starting from the simplest to the most complicated layer, okay, are physical layer, which is layer number 1. You need to know the 7 layers with their names and what happens inside each layer and what is the, what do you call it, the measurement unit of each layer. All of these are questions you will face in your exam and in your networking career. Okay, so layer number 1, the first layer, it starts from the bottom up, 2, 3, 4, 5, presentation 6, and the final application is 7. Layer 1, which is also called physical layer, is for connections. Okay, so layer 1 is for connections. What do you mean by connections? How do we connect our devices? Either wired, so we are using wires, or wirelessly. Okay, layer 1 is everything about the technology of cables and wireless, the types of cables, what is happening inside the cable, how do a cable carries our information. I am sending an email to my friend, and inside this email there is an attachment, there is an image, there is a text in the body of the email that I am contacting my friend. How is all of this carried inside a cable? What is cable doing? And each type of cable, how does each type of cable do behave, using which technology to transform our networking information or our data? Okay, so the first layer is the physical layer. The measurement unit of this layer is the bits. Okay, let's talk more detail about this. We just said that layer 1 is only about connections, and connections are either wires, cables for wired networks, or wireless. Okay, for the first type of networks, okay, which is the wired networks, we use cables, and there is different type of cables. Let's use Microsoft's whiteboard, please. Okay, so first, layer 1, the first type is cables of the wired networks. Okay, what do cables do is that I have a computer trying to talk to another computer, and there is a connection between them, which this connection is a wire or a cable. To be more specific, we always call it a cable. Okay, which type of cable are we using, and what's the differences between each type? Okay, well, the first type of cables in the new course is the copper cables. Okay, the first type is the copper cables. Obviously, all what's inside this cable is only copper. Okay, what can copper do to us? How can copper serves us and serves the networks by carrying data? Is simply by using electricity. Okay, copper can only carry electricity. It can carry the beads, the electrical beads, okay, inside the copper media. On the matter of what was the measurement unit of layer 1 of the physical, bits. And bits is something refers to either a 0 or a 1. What is this? This is something that we will discuss in detail in the upcoming slides, okay, or in the upcoming lectures. The important things that you should know right now is that if I have a single copper wire inside a cable, that is carrying multiple copper wires inside it, this single copper wire is carrying my ones and zeros, my bits, in this way. Okay, 1 refers to something that is happening, 0 refers to something that is not happening, refers to silence. But what you have to understand for now for copper cables is that they always transmit electrical beats between them at a constant frequency, but it's not really at a constant frequency. What do you mean by this? I mean that this PC, once you connect it to this other PC, personal computer, through a copper cable, electricity will start to flow between them. Okay, electricity, in order to flow between them, it will keep flowing all the time. Once there is a 1 bit trying to be transmitted, the frequency of that electricity beat will be increased, and when there is no 1 digits or 1 bits are flowing, it will be decreased. So as long as we have zeros, it will be this way. As long as we have ones, it will be this way. This is how you carry ones and zeros through a copper cable that can only send electric beats. Okay, so this is one of the ways that a cable can carry data, and we will talk more detail just in the upcoming slides. The next type of the cables is called, or the cable technology, I'm sorry, it's called this one is the optical fibers, where we have fibers that are made from glass and they carry optic or light. Okay, so for now we have another type of technology, another type of cables that is carrying, okay, data or information, but it's not through a copper cable, not through electric beats, but through light. So we have now this single fiber that is made of clear glass, and it can carry only light, but it will always send light, but not this way of sending light. Just like in copper cable, it will send light at higher frequencies once there is ones, and at low frequency when there is zeros. Okay, and all these are ones, all these are zeros, ones and zeros, and etc. this way. Okay, this is the other type of cables. We will talk in more detail about them. So this is about layer 1. Let's go back to our slide. Okay, so this is about layer 1, where we have talked about cables. It's a physical layer. Why it's a physical layer then? Because it's about things that we are seeing by our own eyes. We can see the cables and we can connect them together by ourselves. This is something physical that we can use. In wireless networks, this is another different story we will talk about when we reach chapter 6 of wireless networks. Okay, layer 2 is data link layer. Okay, in this layer, information are carried inside what is called frames, which is the measurement unit of this layer. Whatever happens inside layer 2 is carried through frames between devices, between switches, routers, and PCs, etc. Okay, it depends on layer 1, because as long as there is no cable connecting the two PCs, then how can they talk to each other? As long as there is no wireless connection between these two pieces, then there is no data link or frames are crossing. Okay, one of the most famous example on the data link layer is the MAC address, which is something we will talk about when we reach its slide. Layer 3 is called network layer. Okay, this is layer 3. Don't forget, you have to know each layer with its name, measurement unit, most famous or some famous examples, and the number of the layer. Okay, layer 3 is called the network layer. It carries what is called packets. This is something happens between PCs and routers, because routers are the ones who generates and redirects packets. Also PC do generate packets. Layer 4 is called the transport layer. This layer is the one responsible for creating a virtual window between my computer and yours to transport data or information between them, and after that it will close that window, and what happens inside layer 4 is called a segment. Layer 5 is called the session layer. Okay, don't forget, it is layer 5. It's a very important question in the exam. What happens here and in the next coming layers that you shouldn't have the concern about is carried inside datagrams. Session layer is responsible for establishing a temporary session between me and you, just in order to transport the information. After that, this layer also, just like it did create the session, it will terminate the session until we need to transmit again other informations. Then it will re-establish a new session. Layer 6, the presentation layer. This layer is the responsible for applying the correct format for a data so that it will have the correct presentation or the correct appearance for me, for a human to understand, like it applies the correct format for the correct specific data, which should be this way in order to appear as a PDF file. So who is responsible for applying the specific format for a specific data or file? It is the presentation layer, which will do whatever this file is related with: PDF.jpg, which .doc, .xml, whatever this one needs. This is layer 6. I'm sorry, I forgot. Okay, never forget the order of the layers. Okay, the final one is the application layer, layer 7, which also uses datagrams. What happens here? Every application that is used on networks and internet lies within the application layer, like Google Chrome, like Internet Explorer, like all the applications that we use on the network, like the DNS. A lot of applications lies within the application layer. So these are the 7 layers of the OSI model. Okay, these are specific only for the OSI model. What concerns you as a network engineer is to know the first 4 layers in detail and to work on all of them. Okay, the next 5, 6 and 7 layers are not to have this big concern, okay, of your interest. Let's erase all of this. Okay, next we have a more simplified model than the OSI model, but changes no technology. It's just a bit of simplification for the 7 layers to make them only 4 layers. Okay, it was about to merge layer 5, 6 and 7 in a single new layer that is also using datagram, and this layer is called the application. Also, it do merge the first 2 layers, the data link layer and the physical layer, in a single layer. Why? For some reasons that you might catch and we might talk about in the upcoming slides when we talk briefly about cables and MAC addresses. Layer 3 of network was just renamed to internet. Layer 4 of transport kept to be transport layer, which is layer 4, have its own segments, some packets. Here we have bits moving around and frames, okay, and datagrams in the final one. The name of this model, I missed to say the name first, is the Transmission Communication Protocol upon the Internet Protocol model, which is TCP over IP model. This is the next version of the OSI model, which to be preferred by vendors and books right now to be mentioned without mentioning OSI model. But OSI model is more specific and it might help you to understand the idea of modeling much better. Okay, still some layers go through some encapsulation and decapsulation. I have missed talking about what encapsulation, decapsulation. This is special processes that do happens in layer 2, 3 and 4. Okay, for a packet, or I'm sorry, for an information or data to transport or to travel from layer 2 to 3, it will need to have encapsulation. To go from 3 to 4, it will need to have another encapsulation. To go back, it will have a decapsulation and another decapsulation. So this is the concept of encapsulation and decapsulation. That's all for the models. Next, we will start in a specific with layer 1 and what happens in it, but we prefer to do this on the next lecture so we don't confuse a lot of information inside a single lecture. Thank you for watching.